Magandang umaga. Ako nga pala ang guro, si Teacher Billy. Naganda ako ng isang video upang lubos yung maunawaan ang ating aralin. Inyong panoorin at kayo matuto. Salamat.
Hello, welcome back to Algebra. The title of this lesson is The FOIL Method of Multiplying Binomials Explained. And I want to make sure and explain to you whenever I get really excited about teaching a lesson. I love teaching all this stuff, but a few things poke out to me, and this is one of them. Because I remember learning how to multiply binomials. You know, 2 terms times 2 terms. That's multiplying 2 binomials together. And I learned something that you're going to learn in your class, and it's called the FOIL, F-O-I-L, the FOIL method of multiplying binomials. And you're taught that in every algebra class. It's the way that we multiply binomials together. But almost no teacher actually explains to you why we multiply binomials using that FOIL method. And I really don't like that because it tells you that, hey, you have to memorize all these things that your teacher says, and you just do it that way, and there's no reason, just do it that way. It's just the way it is. Well, the truth is the FOIL method of multiplication makes sense. And I'm going to show you what the FOIL method of multiplication is, what multiplying binomials really entails, and why we use that method and why we use those letters. So at the end of this lesson, you should understand how to multiply using FOIL and why we do it that way. And in the next 2 lessons, we'll be getting more practice, two more detailed lessons of more complicated problems to give you practice multiplying binomials together. So before we go any further, I want to recall or have you recall something that we learned in the past, because it turns out that multiplying binomials is related to what we've already done in the past. What if you have x times something very simple, x plus 2? How do you do this? So you learned a long time ago that when you have a term wrapped in parentheses, or 2 terms in this case, a binomial, this is a binomial by the way, 2 terms in parentheses, and you have something on the outside, this is a monomial, then what you do is you take what's on the outside, you multiply it times this term, and you multiply it times the other term, and then you write them out. So what you're going to get is x times x is going to give you x squared, and then x times 2 is going to give you 2x. And the reason there's a plus sign here is because there's a plus sign here. Positive 1x times positive 2 will give you the positive 2x. Now notice here that in your final answer, there were actually 2 terms in answer. Right, 2 terms. This is number 1 and number 2, and that'll become interesting later on. I'll talk to you about it. So the critical thing to remember about multiplying anything in algebra is when you have a parentheses, a set of parentheses, with, in this case, we had 2 terms inside, but actually it can have any number of terms inside the parentheses, right? Then if you have something sitting right outside that parentheses, then you know from the rule of distribution that in order to do all the multiplication, you have to take that outside term and multiply it times every term on the inside, because if you only multiply it by half the terms, then you've only done half the multiplication. That term inside the parentheses consists of 2 things. So in order to do the complete multiplication, the outside thing has to affect everything on the inside. Otherwise, you've only done half of the multiplication. All right, so anyway, you've done it via distribution. Now, let's go and let's change it a little bit. Let's change this to the following thing. Let's change it so that you have, on the outside, instead of x, you actually have a parentheses with something like x plus y. And on the other parentheses, you have x plus 2. Now, for some reason, and I was the same way when I learned this, when a student sees this, your brain starts to go berserk and you have no idea, like, whoa, the alarm bells start going off and all of that. But when you think about it, what's going on here is you're still multiplying something by x plus 2, just like you were doing here. And you know how to handle this. You take the x times this and the x times this and you add them together, right? But now, instead of multiplying by a single thing on the outside, we're just simply multiplying by 2 things linked together with a plus sign. So in order to do a complete multiplication of this times this, the way you handle it is as follows. This first guy on the outside has to multiply into the x, and then this first guy also has to multiply into the 2. Because basically you just pretend the y is not even there at all. If there were just an x out there, then you would just do whoop, just like this, multiply times each interior term. So let's write those down. If you just multiplied x times x, you would get x squared. And if you just multiplied x times the 2, you would get the 2x. Okay, great. But you can't stop there because obviously you have something else out here. If you were to cover up the x. And if you were only multiplying by y, you would multiply y times also each interior term, which would be y times x. You could call it yx, but I'm going to call it xy, just because I like to write it that way instead. And then y times 2 is going to be 2y. And notice that what you've done when you've done this here is there are now no longer 2 terms in the answer, there are 4 terms in the answer. Right? The reason that there are 4 terms is because you're multiplying 2 terms on the inside of something times 2 terms on the outside of something, and in order to get a complete multiplication, you have to multiply every term on the outside times every term on the inside. And then on the other term, every term on the outside here times every term on the inside. So because there's 2 terms in both places, you get 4 terms in the answer, right? So this is actually the answer to this multiplication. We haven't talked about FOIL yet. I'm going to get to that later. Don't worry about it right now. For now, I want you to know that whenever you're multiplying this times a binomial, you just take the outside guy. It has to be distributed to each term on the inside. In fact, what I usually do is I remind you of that by drawing an arrow here to say we're multiplying that times that, and then we're multiplying that times that. And on the bottom, I'll draw an arrow here showing you that I'm multiplying the y also by both terms. That's why you get 4 terms. So these 2 come from the first 2 multiplications of this one, and the last 2 come from these 2 multiplications of that one. That, in a nutshell, is how you multiply 2 binomials together. 2 binomials together. Now, I'm going to give you a little bit of a preview. I don't want to get into the details of it right now. I'm going to get into it in a few lessons, but I want to give you a preview. What do you think you would do if what you were multiplying on the outside did not have 2 terms? What do you think you would do if there was a 3rd term out here, like x plus y plus z all out here? Well, you would have x times these 2 terms, and then you would have y times these 2 terms, and then you have z times those 2 terms, and then you would add them all together. So there wouldn't be 4 terms in the answer, there would actually be 6, because you'd have 3 times 2, and that would give you 6. So you see why I like to teach it this way, because I'm showing you logically how what we're doing is a direct result of what you've already done with distributing regular terms. So now you can multiply this, and you know what's happening. You're distributing each term, and then later on, if I give you a much, much more complicated expression, then you can just do it because you know that every term has to go in and multiply by every other term. So then, let's take another example. We're going to fly through a few examples now to give you a little more practice. What if I have x plus 6 multiplied by x plus 4? Well, it's the same kind of thing. I have to take the x and multiply it by the first term, and then I have to take the x and multiply it by the second term, which is going to give me what? X times x gives me x squared. X times 4 gives me 4x. We generally write the number first. And then I'm going to have this secondary term multiplied in by each of these as well. 6 times x is 6x, and 6 times 4 is 24. Now notice I got 4 terms here, just like I did here. The only difference is when I look at this, I realize I have a 4x and I have a 6x. So actually I can combine these two and add them because they're like terms. So I'll have x squared plus, this will be 10x plus 24. And that will be the final answer, x squared plus 10x plus 24. All right. Want to do, let's do one more on the next, let's do a few more on the next board, and then we'll talk a little bit about FOIL. All right, so then for the next one, just to get some more practice, y plus 7 multiplied by y minus 3. So you pretend the 7 isn't here at all, and you just now, I'm going to stop drawing my arrows for every problem. This will probably be the last one that I do. But this y needs to be multiplied by each term on the inside, distributed in, as you would guess. So then what we're going to have is y times y is going to give you y squared. Y times a negative 3 is going to give you negative 3y. But then after you're done with that, to complete the multiplication, the 7 has to be multiplied here, and it also has to be multiplied by there as well. So what is 7 times y? It's 7y. What is 7 times negative 3? That's negative 21. Then I say I'm done with 4 terms. However, I can add these together. They're like terms. So I'll have y squared. What is negative 3 plus plus a positive 7 is plus 4y. And then I'll have a minus 21 here on the end. Y squared plus 4y minus 21. That's the final answer to that problem. All right, let's take it a little bit more complicated, just a notch. Not too bad, though. What if we had 3x plus 1 multiplied by 2x plus 5? So it's going to be the same thing. The only difference is the first term here actually is 3 times a variable. The first term here is 2 times a variable. And in fact, all the other problems, we just had single variables and single digit things everywhere, but exactly the same thing applies. We have to take this 3x and we have to multiply it times both of those guys over on the other side. So what is 3 times 2? It's going to be 6. And what is x times x? You add the exponents, giving you x squared. Now you have to take this and multiply and distribute into the other guy, which is 5. 3 times 5 is 15. And the x is still multiplied, 3x times 5, so it's 15x. Then we'll take the 1 times the 2x, giving you 2x. And we'll take the 1 times the 5, giving you a 5. And then we realize we can combine these like terms, so we'll have 6x squared. What is 15 plus 2? It's 17x, and then the 5 comes along for the ride. So 6x squared plus 17x plus 5. All right, so what I want to do is, first of all, call your attention to the fact that we talked about how to multiply these binomials together using nothing more than an extension of what you already know, how to distribute things on the outside. And now you know that when you have two terms linked together, then they have to be each multiplied by everything, each distributed in to the following term. Now let's zoom in to one of these examples a little closer, this one here, the x plus 6 and the x plus 4. I'm going to do that on the other board, and we're going to talk a little bit about FOIL, and you're going to see the punchline is that the FOIL method of multiplication, which they teach you in class without telling you what it's for, is exactly what we've just done here. So you're really learning nothing new. Let's examine one of these a little bit further. Let's say we have x plus 6 multiplied by x plus 4. So I'm choosing this one because we've already done it before. So the x times the x, let me go ahead and, for this one case, I'm going to go ahead and do this, draw my little arrows because I'm going to be coming up that direction. I'm going to do a different color for the bottom ones, like this. So when we do the first guy, x times x will give me x squared. And then 6 times, x times the other guy over here will be 4x. X times 4 is 4x. Then we have the 6, the second term, times x will give you 6x. And then the 6 times 4 is 24. Let me just double check I didn't make any silly mistakes so far. All right, notice what we've done. I've explained it to you as distributing in from the outside, which is all correct. But notice that there's an easy way to remember this for people that don't learn it what I consider to be the right way, is that the first thing that we multiplied together is the first terms. In other words, this is the binomial and this is another binomial. These are the first terms. The x and the x are what we call the first terms because this is the first term of this one and this is the first term of this one, right? So this guy, I'll go ahead and draw it out here. This is called first terms. And that was x times x, right? And so because it's first terms, we're going to put an f there. And then after that, we multiplied x times 4, but this is the outside terms, right? So these are the first terms of each guy. This x times the 4, these are the outside terms. They're on the outside most part of the parentheses. So this guy here is what we call outside terms. So we call that O, and that was 4 times x. All right. Then notice that we multiplied the 6 times the x. These are the inner terms, the most inside most terms. So we label this inside terms, 6 times x, and we call that capital I. And then these are the last terms in each of the two binomials, 6 times 4. So we label that the last terms. And it was 6 times 4, and it was last. So this is the famous FOIL method of multiplication. First, outside, inner, last. Typically, what most algebra teachers, what most algebra books are going to do is they're going to say, hey, when you're multiplying two binomials together, like, you know, in this case, it's x plus 4 and x plus 6. When you're multiplying two binomials together, follow this recipe called the FOIL method. FOIL means first, O means outside, I means inner, and L means last. So the first terms are these two terms, the outer terms are these two terms, the inner terms are these two terms, and the last terms are these two terms. And all you have to do is first multiply the first terms together, giving you this, the outside terms together, giving you this, the inside terms together, giving you this, and the last terms together, giving you this. So it's first, outside, inner, last. And you follow it like a cookbook. First, outer, inner, last. First, outer, inner, last. And it works every single time because you write your first, outer, inner, last multiplications, then you add these together, and you get the answer, and it's great. There's nothing wrong with using the FOIL method. In fact, as we work more problems in the next few lessons, I'll probably refer to the FOIL method subconsciously because I learned it myself when I learned algebra. So why am I harping on it? Why didn't I just open this lesson up and say, hey, there's something called the FOIL method, you have to use it? It's because it doesn't help you if any problems exist beyond multiplying binomials together. It doesn't help you for any more complicated type of situations. Let me give you an example. Before we get there, let's do one more, as we now know that this is called the FOIL method. Let's take a look at 2x minus 3 times x plus 8. All right, so I've been teaching you just to distribute things in, and that's fine. It's exactly what we've been doing, but you could also just think of the FOIL method. Hey, here's the first terms, 2x times x, that's 2x squared. The outer terms will be, this is an outer and this is an outer. 2 times 8 is 16, so you get 16x. The inner terms will be negative 3 times x, you have a negative 3x. And the last terms would be this one here, negative 3 times 8 is negative 24. And then you can add these, so you get 2x squared. What do you get? 16 minus 3 would give you 13x minus 24. Let me just double check them right before I continue on. Yeah, that's the right answer. So you see we did first multiplications, then outer, then inner, then last, which is the exact sequence that I taught you initially. In other words, the FOIL method is exactly what I already told you. The first terms is when you distribute this in. The outside terms is when you distribute this in. The inner terms is when you distribute this in. The last terms is when you distribute that in. So why am I making such a big deal out of it? It's because people memorize this recipe first, outer, inner, last, but they have no idea why it works. So then, later down the road in algebra, maybe I give you this. Maybe I give you, which we will get to, 2x squared plus 3x plus 2 times x minus 1. You see, if you've learned the FOIL method, first, outer, inner, last, then you have no idea how to multiply this. What's the first terms? What's the outer, inner, and last terms? How do I do it? You have no idea how to handle anything beyond this cookie cutter recipe if you just memorize a cookie cutter recipe. But hopefully now you all realize that there's no magic behind how you multiply this together. What you do is you realize this term has to be distributed into each of these, like this. Right? Then this term needs to be distributed in to each of those terms, like this. Then that last term, which is kind of hard to show without getting in the way here, has to be distributed in as well, right? So even though we're getting a little bit of ahead of myself, I think it's really important for you to see 2x squared times x will give you 2x to the third power because you're going to have an adding of the exponents. Then 2x squared times minus 1 will give you minus 2x squared, because negative 1 times that's 2x squared. Then you move to this term, and it has to go into each one as well. 3x times x is 3x squared, because x times x, you add the exponents. Then 3x times negative 1 will give you negative 3x, right? Then you go to this one, which has to be distributed in. 2 times x is 2x. And then 2 times negative 1 is, I'll have to write it on the bottom, unfortunately. Yeah, I'll do it here, negative 2. Like this. So you see what's happening? You have now 1, 2, 3, 4, 5, 6 terms, because this one goes boom, boom, this one goes boom, boom, this one goes boom, boom, and you don't ever talk about FOIL because it doesn't matter. And then if I give you another problem where this one has 3 terms, then you know how to do the same thing, and it works for any multiplication of any polynomials, which we're going to get to a little later. This is a little bit of a preview. Of course, I can simplify this by adding these terms. I can simplify this by adding those terms. I'm not going to do it now because this isn't the point of the lesson. The point of this lesson is that we're learning something called the FOIL method, first, outer, inner, last. But it's not a magic recipe. It's developed because we multiply binomials by distributing every term into every other term. Hello, welcome back to Algebra. In this lesson, we're going to cover what we're going to call special products of binomials. This will be part 1 of 2. So in this lesson, I want to introduce the concept of special products. I'll give you an idea of where they come from so you're not just randomly memorizing things. And we'll do a couple of problems here, but in the next section, we'll really roll up our sleeves and get a lot of practice. So what do we mean by special products of binomials? Up until now, we've multiplied binomials together. And remember, we used the thing to help us remember, FOIL, but I've been stressing over and over again that that's really just the concept of distributing things in, from the outside to the inside of whatever you're multiplying by. So FOIL is helpful to remember how to do it, but ultimately that's all we're really doing. Now, there are a couple of special things, special products that pop up over and over and over and over again in algebra. And they actually have really neat results and special simplifications that are just, it's something that's occasionally worth memorizing. I don't usually like to tell you to memorize things, but in this case, we're going to be using these so many different times that we're going to derive them, we're going to talk about them, but ultimately you probably will go ahead and need to memorize these as we move on through algebra. The good news is they're very, very simple and they're not hard to understand. So let's take, for instance, the very first case. What I'll do is I'll work on the right-hand board, we'll talk about everything, and then at the very end of the day, what we'll do is we'll move over to the left here and we'll write a summary of everything to help us in our future problems. All right, so just for example, let's take a look. What would happen if you had to multiply these binomials together? A plus B, and you wanted to multiply that by A minus B. Now, A and B are variables, of course. The only difference between this term and this term is just that one is joined by a plus sign and the other one is joined by a minus sign. Now, when you see a multiplication of binomials like this, you handle it the same way we've handled all multiplication of binomials. So you can think of it as FOIL if you want. I like to think of it as just distributing the A into both terms. So A times A is going to give you A squared. You add the exponents. A times negative B is going to be negative AB. And you're done with multiplying in A, so you move over here and you multiply B times A. Of course, you can rewrite it the other way, making it A times B. In other words, I could write it BA, but I'm going to write it as A times B because I know I'm going to be matching terms up here. And then finally, after going in here, I'm going to multiply B times negative B, which will give me negative B squared. Now you see, because this is a special case of A plus B times A minus B, what happens is that these two terms in the middle, AB is negative here and AB is positive right here. So these two terms actually go away and make 0. So what you're going to end up having when you have A plus B times A minus B is going to be, in this case, you can just see it right here. It's just going to be A squared minus B squared, right? A squared minus B squared. So what we really want to write down, even though we have it here, something to remember for the future, is that basically anytime we're multiplying something that's of the form A plus B times A minus B, of course we can multiply it all out and cancel and make this 0 every time. But if we happen to recognize that it fits into this form, then we already know without doing all of this FOIL that the answer is just going to be A squared, whatever the first thing is squared, minus B squared, which is whatever the second thing is squared. Right? So this is something to remember, and because of that, I'll kind of put a little circle around it. I'll go ahead and summarize it over on the other board, but in algebra textbooks, you will see things like this. And it will tell you, hey, if you ever see A plus B times A minus B, it always equals this. And a lot of students go, well, thanks, but where did that come from? It comes from exactly this. When you multiply the variables out and get all of the cross terms, what you get is a cancellation. And this cancellation going to 0 will happen every single time you're multiplying any two binomials of this form. So just to give you a concrete example of when this would actually be used, just one simple example. We'll do more complicated examples later. But just as an example, what if you're multiplying the binomial x plus 2 times x minus 2? First of all, check to see if it's of this form. This A plus B, A minus B can be anything. They can be variables, they can be numbers, but what it's saying is the first thing here has to match the first thing here, just like these match. The second thing, whatever it is, has to match the second thing here, which the 2's match. And you have to have a plus sign in the first and a minus sign in the second, right? Like this. And whenever you have it of that form, you of course can go and do the FOIL. That's absolutely fine. If you forget any of this, no problem. But if I happen to recognize that it actually is of this form, then without doing any actual multiplication, I know it's going to be the first term squared, x squared, minus the second term squared, which is 2 squared. So I know the answer is going to be x squared minus 4. So you see, I didn't actually have to do any FOIL, but that's only because this is a special case where it's a plus b times a minus b, where a and b can be anything, any variables and any numbers, as long as they match and they're of that form, and one is a plus and one is a minus term, right? Then what ends up happening is it always comes out to in this case, x squared minus 4. Now, if you were going to do it the long way, which is absolutely fine if you forget this, then the way you do it is you take the first terms, you make it x squared, the outside terms, negative 2x, the inside terms, positive 2x, and the outside terms, negative 4. So you can see right away you're going to get x squared minus 4. So the moral of the story is, with these special products in algebra, try to remember them. Because oftentimes when you're multiplying and you're simplifying a very large equation, you might come across something of this form very often. It's too complicated to explain now why you will come across that, but very often you will see that kind of thing pop up. If you do, and you forget this stuff, it's absolutely fine just to multiply it out just as you always do and get the answer. But if you happen to recognize it's of this form, then you can save a little time just by writing the answer down. First term squared minus second term squared, that's going to be the answer, no matter what the details are inside of here. So that's one of them that we want to remember. Let's move on to another one that's equally important. What if you had a binomial, a plus b? Remember, a and b can be anything, numbers, variables, whatever, but it's a binomial, and I'm squaring that binomial. So first of all, what does squaring a binomial mean? What does squaring anything mean? 2 squared means 2 times 2. 3 squared means 3 times 3. 17 squared means 17 times 17. So a plus b squared just means the entire quantity a plus b multiplied by a plus b. In other words, it's multiplied by itself, and there's 2 of them here because it's squared. So of course, you don't need to memorize the special formulas here. What you need to do is just know how to handle everything by hand, right? So if we were just going to multiply everything out, it would be the first terms, a squared, and then distribute a times b, giving me plus ab. And then the inside terms would be ba, but I'm going to write it backwards and make it ab so I can join it with this other term here. And then distribute the b into the last term, being b squared. This is exactly FOIL, right? But you notice that this term matches this term. Now, they're both positive, so they don't go away. They don't cancel. However, what we get is a squared plus ab gives me 2 times ab plus b squared. All right? So the bottom line is, anytime I have a binomial like this, where a can be whatever and b can be whatever, but I'm squaring that binomial, then it is always going to look like this in the answer. A squared plus 2ab plus b squared. So let me just write that down and show you what I mean. So if you have a plus b squared, of course you can multiply it out as we've done here, but if you happen to remember that it's of this form, a squared plus 2 times a times b plus b squared, it's actually a faster way to get to the answer. So I'm going to circle this because it's something that we're going to need to remember. This is something, whoops, I wrote this down wrong. It's a plus b inside the parentheses. The entire quantity is squared on the outside. So what this means is, if you're given anything, something plus something, and you have the whole quantity squared like that, then really you can kind of think of this square term as going in and affecting the a, making a squared, then going and affecting the b and making b squared, but there's an interior term that comes about, which is because of both of the terms there, which is 2 times the first thing times the second thing here. Now, you do have to memorize this. If you forget it, if you don't remember it, if you're on a test and you can't remember, is it 2ab, what is it? Then just forget it. Just write it out like this and just do everything manually as we have done. But if you can remember this, then it can save you a lot of work, because then you won't have to do all this stuff and add the interior terms. And as you might guess, squaring things in algebra happens quite a lot. So you're going to run into this often. So an example of this would be, for instance, x plus 3 and I'm going to square that. So you see, a and b can be anything, in this case x and 3, but whatever it is, it's squared. So of course I can do it the long way, no problem, but the shorter way would be, well, I know it's going to be the first thing squared, which would be x squared, plus 2 times the first thing times the second thing, 2 times x times 3. Just write it like this for right now. 2 times a times b, which is the first thing times the second thing, 2 times x times 3, plus the last thing squared. And I can clean it up in the next step. X squared plus 6x plus 3 times 3 is 9, and this is the final answer. So x squared plus 6x plus 9. If you don't remember this, if you have a hard time remembering this, then forget it. Just write this as the product of two binomials, which you can, of course, do. So we can write it another way. We can say this is, if you forgot that thing, x plus 3, x plus 3. How do we do it? We take the first terms, we distribute it in, making x squared. And then x going in times the 3 gives me 3x. We're done with that, so we move here. 3 times x gives me another 3x. And then 3 times 3 gives me 9. And you can see right away, these are going to give you 6x, and everything else matches exactly. So if you forget these little shortcuts, fine, just write them down and multiply them out. But I can tell you right now that squaring binomials will pop up a lot from here on out. So it is worth your time to try to remember that, but will probably remember it on your own without any work as we go forward, because you're just going to see it so much. Now, along those lines, actually I want to do it on the same board. Along those lines, oftentimes, you will find something similar. Instead of a plus b squared, we also run into this a lot, a minus b squared. So it's exactly the same. A and b, everything's the same, except it's a minus sign instead of a plus sign. And when we do that, how do we handle it? If we were to do it manually, it would be the following. A minus b times a minus b, because I've squared the thing, right? So if I take these terms, I'll get a squared. If I distribute the a times negative b, I'll get negative ab. Then I move over here, negative b times a will give me negative ab again. And then this is where you can get tripped up here. Negative b times negative b, negative times negative is positive, and b times b is b squared. But these can be added together, except they're negative, which it's a little different because they were positive before, but these are negative now, so I can have a squared minus 2ab plus b squared. So the moral of the story here is, if I have the exact same thing, where the only difference by a minus sign, a minus b squared, then it's going to be very similar to before. It'll just be a squared minus 2 times a times b plus b squared. And I'm circling the things in purple that are worth remembering. I know it seems like I'm just throwing a bunch of stuff at you, but this will become very easy for you to do as we work problems, because you're going to run into this a lot, right? So to give you just one quick concrete example of that would be, for instance, what if I had x minus 4 squared? You see this in an equation somewhere, and you need to multiply that out, okay? Well, if you recognize, hey, it's a binomial square, then I can just do that very easily by taking the first thing and squaring it. A minus sign, because it's minus on the inside, 2 times the first thing times the second thing, and then plus whatever the last thing is squared, like this. Then what it'll end up being is x squared minus 8x plus 4 times 4 is 16. Let me double check myself. X squared minus 8x plus 16. All right? And that's what I'm going to basically get. Negative 4 times negative 4. There you go. Now, if you were to multiply this x minus 4 times x minus 4, I'll leave it to do yourself, but it's going to look exactly or very similar to what we've done up here, and you'll get exactly the same answer. So the bottom line is, I have given you a lot of extra problems, but there's only really 3 things I want you to remember in this lesson. There's the first one here, there's the binomial squared here with a plus sign, and then there's the binomial squared with a minus sign. And they're so important that just to help you remember, and also because I want to leave them on the board for the next lesson, I want to go ahead and put them up here. So these don't have particular names, but if you have a plus b multiplied by a minus b, so these aren't squared, they're different because one's plus and one's minus, it will always work out to a squared minus b squared. And then the way I'm going to write the next one is a little bit different than the way you'll probably see it in most books, but I like it like this because it helps me remember what to do. Let's write it as a plus or minus b squared. See, I notice I put a plus or a minus here because in some cases it might be a plus b, in other cases it might be a minus b. So the answer that you should get from that will be a squared, and then plus or minus 2 times a times b plus b squared. Notice I have a plus or minus here. The way you read this is, if it ends up being a plus b, that's the top sign, a plus b means it's going to be a squared plus, I choose the top sign, 2ab plus b squared. In other words, if I choose the top sign here, I choose the top sign here. If I choose the bottom sign, if it's a minus b, then it's a squared minus the bottom sign here, 2ab plus b squared. That matches exactly what I wrote on the board. This is called the difference of two squares here, because I have two things squared and I'm taking the difference. It's a plus b times a minus b. And these things in purple are exactly the same thing. When you have a plus sign, it's a squared plus 2ab plus b squared. When you have a minus sign, it's a squared minus 2ab plus b squared. So plus goes with plus, minus goes with minus, which is the reason I wrote it this way. Plus goes with plus, minus goes with minus, and it's a little bit more compact on the board. So I'm going to leave this on the board, and we're actually going to use it to solve more examples in the next lesson. I want to stress to you that these special products of binomials are not something that you have to memorize. It's something that makes your life a little bit easier when you're solving an equation and you happen to know, or you happen to notice, that the binomials that you're squaring or multiplying take these special forms. They can save you a little work. But